Imagine standing on a shoreline where the horizon itself feels restless, as if the ocean is whispering secrets from the deep. Beneath those rolling waves, the very bones of the planet are shifting. Invisible to the human eye, colossal slabs of rock, tectonic plates, grind, collide, and dive beneath one another in a slow but relentless ballet. It is here, along the fiery circle that rims the Pacific, that Earth bears its most volatile soul. 75% of the planet's volcanoes, 90% of its earthquakes, all chained together in one colossal belt of unrest, known as the Pacific Ring of Fire. But what if this familiar narrative is only part of the story? What if something far older, far larger, and far more enigmatic still lurks in the shadows of the Pacific? The year 2025 has already proven how alive this planet is. On July 30th, the Kamchatka Peninsula trembled as a magnitude 8.8 megathrust earthquake ripped through the seafloor at nearly 20 kilometers depth. The ocean convulsed, displacing enough water to hurl tsunami waves up to 16 feet high across the North Pacific. Volcanoes in Kamchatka, giants that had been quiet only weeks before, suddenly began to stir with tremors and smoke. 2 weeks earlier, Alaska's Aleutian Arc had shaken with a magnitude 7.3 quake south of Sandpoint, the ground shuddering along the same trench that has birthed some of the most devastating earthquakes in modern history. And these were not isolated events. In March, New Zealand's South Island rattled as a magnitude 6.7 quake struck just 10 kilometers beneath the southern Alps. July brought tremors to Sulawesi, and August shook West Papua with magnitude 6 level quakes. Even South America joined the chorus, as northern Chile quivered beneath a magnitude 6.6 on June 6th. Everywhere along the Pacific Rim, the Earth seemed to roar with reminders that it is anything but stable. Why is it that the ground beneath our feet seems so alive? And what force ties these distant disasters together? The answer lies in the Pacific Plate, Earth's largest tectonic slab, ceaselessly moving westward at up to 10 centimeters a year. It crashes into smaller plates, dives into trenches, and powers volcanic arcs. Its collisions ripple across oceans, unleashing waves and fire. Yet even with all the chaos at the margins of this plate, there is one place, silent, massive, and almost forgotten, that may eclipse them all in scale. East of the Philippines, in a deep stretch of the Philippine Sea, lies an ancient scar hidden beneath the waves, the Apolaki Caldera. Discovered only a few years ago during marine surveys of the Benham Rise, Apolaki is not just another volcanic crater. At 150 kilometers wide, it is the largest caldera ever identified on Earth, nearly twice the size of Yellowstone. To put that in perspective, imagine ago. The discovery of Apolaki stunned scientists. Marine mapping revealed its scalloped rim, terraces descending into a vast depression, and even a central dome. Signs that magma once swelled and retreated in cataclysmic cycles. Beneath it, drilled samples revealed layer upon layer of volcanic rock, stacked more than 15 kilometers thick, erupting between 47 and 26 million years ago. That time frame places Apolaki's fury in an era when the planet itself was reorganizing, when mantle plumes surged upward in extraordinary outbursts of molten rock. Eventually, after countless eruptions, the chamber beneath emptied catastrophically. The roof collapsed, leaving behind the titanic scar we now know as the Apolaki Caldera. Pause for a moment and consider its scale. Yellowstone, the supervolcano most people fear, has erupted with volumes between 600 and 2,500 cubic kilometers of magma in single events. Its chamber still seethes today, feeding ground uplift and hydrothermal outbursts. Gackle Ridge in the Arctic, the only known mid-ocean supervolcano, unleashed 3,000 cubic kilometers of basalt just over 1 million years ago. Even the legendary eruption of Toba, 74,000 years ago, which some believe nearly drove humanity to extinction, expelled about 2,800 cubic kilometers of ash and magma. Apalaki, though older and likely basaltic in composition, overshadows them all in diameter. Its 150-kilometer maw, a reminder of an eruption so colossal that the ocean floor itself caved in. And yet, unlike Yellowstone or Toba, Apalaki is silent. There are no geothermal plumes rising through the water above it, no earthquake swarms rumbling in its depths, no signs of heat or uplift. It is, as far as science can tell, extinct. But here lies the haunting question. Can something that once unleashed such unimaginable energy ever truly be considered gone? Or is its silence simply the long breath of a giant between acts? The earthquakes of 2025 push that question into sharper focus. Could the same tectonic forces rattling Alaska, Chile, and Kamchatka also be stirring the foundation of Apalaki's ancient chamber? Geologically, to resurrect a caldera that has slumbered for tens of millions of years would require rare and extraordinary alignments. Pockets of molten rock would need to survive within the crust. A new source of mantle heat, perhaps a rising plume, or an abnormally hot edge of a subducting slab, would have to inject energy into the old volcanic system. Fractures opened by tectonic strain might create pathways. And under the weight of the ocean, magma-water interaction could turn even modest intrusions into cataclysmic explosions. Does Apalaki fit these conditions today? Scientists say no, at least not yet. The Philippine Trench to the west is alive with subduction-driven volcanoes, but Apalaki sits isolated on the extinct Benham Rise, detached from the plate margins that fuel volcanic arcs. Stress from even the mighty 8.8 quake in Kamchatka dissipates across vast distances, unlikely to rattle rock so far away. No anomalies in seismic waves, no whispers of magma beneath its crust, no swelling of the seabed have been recorded. Apalaki seems sealed, frozen in time. But absence of evidence is not the same as evidence of absence. The ocean hides secrets far more effectively than land. Unlike Yellowstone, which bristles with instruments measuring every shiver and sigh, Apalaki lies in an unmapped wilderness of water and stone. No permanent seismic stations, no GPS trackers, no satellite eyes tuned specifically to its floor. If changes were occurring deep below, would we even notice until it was too late? Here lies the unsettling paradox. Apalaki is, in all likelihood, extinct, a monument to a fiery past. And yet, the very size of it, the sheer magnitude of what it once unleashed, commands humility. Earth has a way of defying certainty. After all, who would have expected the Gackle Ridge, a frozen remote spine beneath the Arctic Ocean, to hide a supervolcano that erupted just a geological blink ago? So what does Apalaki truly represent? A silent fossil? Or a dormant titan waiting for conditions that may, someday, return? To imagine what an awakening of Apalaki might mean, one must step into the language of extremes. Calderas on land are dangerous enough, but what happens when such a colossal system lies entirely underwater? At depths between 718 and 4,510 meters, Apalaki rests beneath crushing pressure. On one hand, this immense weight of seawater suppresses volcanic explosions, smothering them compared to eruptions on land. On the other hand, should magma find a way upward and breach into seawater, the reaction could be catastrophic. When molten rock meets water, the result is not gentle steam, but violent flashes of superheated vapor that can rip entire chambers apart. The 1883 eruption of Krakatoa showed the devastating potential of this process. where magma interacting with seawater produced colossal blasts and triggered one of history's deadliest tsunamis. Now scale that to a volcanic structure 150 kilometers wide, and the mind quickly confronts possibilities that are difficult to grasp.
This is why Apalaki unsettles scientists, not because it is showing danger now, but because its very existence proves that Earth is capable of creating monsters that dwarf most of what we know. Consider Toba in Indonesia, which erupted about 74,000 years ago, releasing more than 2,800 cubic kilometers of ash and gas into the sky. Some researchers argue this plunged the planet into a volcanic winter, cutting sunlight and dropping global temperatures by several degrees. Agricultural collapse, famine, and near-extinction pressures on early human populations may have followed. If Apalaki ever produced even a fraction of its original force again, its effects would not simply be regional. They would be global, reshaping climate systems, food chains, and societies far beyond the Pacific. But let's pause. Why speculate on reawakening when every measurement today suggests silence? The value lies not in fueling fear, but in cultivating humility. Apalaki may indeed be a fossil, sealed off by cooled rock, its magma chamber long crystallized. Yet Earth is a master of surprise. The Long Valley Caldera in California, for example, appeared dormant for tens of thousands of years before subtle uplift and seismic swarms in the late 20th century revealed its still-held pockets of molten rock. Similarly, Iceland's volcanic systems have been triggered into activity by distant tectonic stress, showing that even quiet volcanoes can find a way to breathe again under the right circumstances. Could Apalaki do the same? For that, 4 key ingredients would need to align. First, there must be a supply of heat, a mantle plume or unusual mantle upwelling capable of recharging the crust beneath Benham Rise. Second, fractures in the thick oceanic plateau would need to reopen, providing channels for magma to ascend. Third, the composition of the magma would determine the style of eruption. Fluid basalt would spread in immense lava floods, while evolved magma could drive catastrophic blasts. And finally, the interaction with seawater would determine whether the eruption remained a submarine curiosity or exploded into a global calamity. At present, there is no seismic tomography revealing a mantle plume beneath Apalaki.
No deformation, no gas anomalies, no swarms of earthquakes mark its presence. In this sense, it differs sharply from Yellowstone, where uplift of up to 75 millimeters per year betrays the restless pulse of magma beneath. It differs from Eira in Japan, where Sakurajima erupts frequently and small explosions hint at the larger system below. It even differs from Gackle Ridge, which despite being underwater revealed its volcanic youth through vast basalt deposits dated just 1 million years old. Apalaki is older, colder, and quieter. Yet its silence may say more about our lack of monitoring than about its true state. This brings us to a critical point. The oceans are Earth's blind spot. More than 70% of the planet is covered by water, yet less than a quarter of the seafloor has been mapped in high resolution. Volcanic arcs beneath the seas erupt continuously, often unnoticed until plumes of discolored water or swarms of dead fish rise to the surface. If a caldera the size of Apalaki were stirring, how would we know? Our satellites can detect changes in the ocean's surface, but the resolution is too coarse to catch subtle uplift. Our seismographs listen for earthquakes, but few are stationed in the Philippine Sea, where Apalaki rests. In truth, we may already be blind to movements beneath its crust. The ocean hides its secrets well. That is perhaps the most sobering lesson Apalaki offers: how little we understand about Earth's submarine giants. For every Yellowstone on land that we can measure with precision instruments, there may be dozens of Apalakis beneath the waves, unmapped and unmonitored. Humanity tends to focus on what it can see, yet the greatest volcanic structures may lie hidden under kilometers of seawater. What forces have shaped them? What stories do they tell about Earth's mantle? And crucially, could they one day shape our future in ways we are unprepared to face? If Apalaki were to erupt, several scenarios emerge. In the least dramatic case, fresh basaltic magma could rise and spill out in enormous undersea lava flows,
altering the seafloor topography and creating new marine landscapes. Such an eruption, while massive, would likely remain hidden from most of humanity, impacting only deep ocean ecosystems. But in a more severe scenario, if evolved magmas rich in gases were present, the interaction with seawater could produce a chain of violent explosions, capable of launching tsunamis across the Pacific. The release of sulfur dioxide into the atmosphere, even from an undersea eruption, could veil the skies, scattering sunlight and cooling global temperatures. Crops might fail, supply chains might break, and nations could find themselves grappling with a crisis born not of war or politics, but of fire hidden beneath the sea.
Of course, the scientific consensus is clear. Apophis is most likely extinct. The energy that built it has long since faded, the mantle plumes that fed it, gone. But here is where the comparison to Yellowstone, Toba, or Ira becomes useful. Each caldera, active or extinct, teaches us something about the extremes of Earth's behavior. Yellowstone shows us what an active supervolcano looks like, breathing and shifting beneath our feet. Toba shows us the scale of devastation a single eruption can unleash on global climate and humanity. Ira shows us that calderas can feed smaller but relentless eruptions for centuries. And Apophis, larger than them all, shows us that Earth's capacity for upheaval reaches beyond even our worst imaginations. To dismiss it as merely extinct is to ignore the larger lesson it carries, that Earth's history is marked by episodes of extraordinary violence, far beyond the scale of human memory. Our species has only been here a moment in geological time, and yet we live on a planet that has erupted with forces capable of reshaping entire continents. Apophis is not a threat today, but it is a reminder. It reminds us of what Earth has done, and therefore what it could one day do again. Whether in the Philippine Sea, don't forget to like, share, and subscribe. There are more hidden stories of Earth waiting to be told, and together, we'll keep uncovering the secrets of the restless world beneath our feet.